Okay, let us start today's concept. So let us try to extend the yesterday's concept. So in the last class, we discussed about the introduction to the microprocessor, and also we saw the basic functionalities of the microprocessor. Today, let us extend that, and let us see the algorithms it is used by that microprocessor, and also one pass or two pass microprocessors, and also the data structures used. So that's what we'll see today. So let us continue for today's session. Yeah. So any one of you just acknowledge me. My screen is visible, right? Any one of you acknowledge my screen
Yes, sir.
is visible? Okay, thank you. So yeah, so today let us continue that. So in the last class we discussed about how to whenever we had given the input so any source program, any source code with the macros, when you had given it as an input to the microprocessor, how it is going to expand that code which will be given as input to the assembler to generate the object code. So this how does the microprocessor will expand the given source code to the this is what and produce the resultant expanded code. So we had given this as the input, and this is what the output what we got. Every macro instruction is expanded based on the macro prototype. So now let us continue as microprocessor design. So when you talk about designing the microprocessor, so however we had discussed about the assembler and also the loaders. So the assembly process and also the loading process do happens in the two passes. We used to call it as a pass one and pass two. So here also does this also happens in the two passes in the sense. Yes, few others will say that yes, it can happen in the two passes. But let's say that now let us see where at the time of designing, if they are considered with respect to the two passes, so how it can able to or how can you do it, and how can you achieve by using the one pass? That's what today let us see that. So yeah, so let's see about the two pass and the one pass, and what is the necessity of one pass as well. So here if you come across the two pass microprocessor, so you can observe right here the pass in the pass one, as you are saying the two passes, so it will be as two levels, either you say two steps or two phases. In the phase one or the pass one, what is going to happen in a sense, first you need to recognize where all the macro definitions are available, then you in the pass two you need to recognize the macro calls. So what I mean to say for this example, so what I mean to say about these two statements in the sense, here let me take up this example. So first I should know where exactly my macro definition. So this is what the macro definition. First in the past one, you need to recognize, or the microprocessor supposed to recognize where and all these macro definitions are available. In the past two, in the it has to recognize where from where it is called. So this is where it is, this is where you are calling this macro definition. So in the past one is supposed microprocessor supposed to find out where exactly it is defined. In the past two, it has to identify, or it has to find out where exactly it is called. Like that we divide it into the pass one and pass two. We used to call it as a two pass microprocessor. But there was a major problem with this, so which cannot be handled by this two pass microprocessor. That is when it comes to the nested macro definitions. What do you mean by nested macro definition? However, you know about the nested functions. So nested macro definition, something like a macro definition is defined inside the body of the other macro definition, which however you say that function inside the function. So here also you say that either you call as a nested, or you may also call as a recursive. So where the macro definition is defined inside the other macro definition. In such kind of macro definitions are not handled or cannot be handled by the two pass macro processor. The reason that, so here you're supposed to understand one thing, that whenever you talk about the two pass, first it has to complete the pass one. What is the password? It has to recognize all the macro definitions, then it has to go to the recognizing the macro calls. But in case of nested macro definitions, so inside the macro definition of one of the macro, there will be the other macro call. It is something like, so it is inside the A, there will be a call to the B. Again inside the B, there is a call to the C. So if such kind of things are there, assume there is a macro definition A here. Inside that there is one instruction that is actually calling the macro of B. B definition is here. Again from the B there is one instruction which is again calling the macro definition of C. So again from C you are calling the D. Like that, if there is a nested macro definitions, then you can't make sure that these two steps in the two levels, you can't make sure that right after macro definition itself I will go to the macro calls. That is, you can't solve that. It will be just like an infinite loop, so which doesn't have the solution. So even if, for example, let us take up one of the, this is the case study of the macro recursive macro definition. This is where you can understand better. You can, if you understand from here, see, this is the beginning of this one of the macro. This is the MAC RO. It is not MAC OR. It is a MAC RO macro. This is the beginning of one macro. What is the name of the macro? It is macros. If macro is initialized here or started here, which is this, which is the name of that macro is this macros. Whereas inside that there is a beginning of one more macro. What is the name of it? It is the read buffer. Again, right after this read buffer is end, again you're initializing one more macro inside that, which is what? Write buffer. So again, so here if you observe like this, inside one macros is one of the macro definition or macro prototype. Inside that there are two more macros. So you can observe this read buffer is one macro and the write buffer is one macro. Both are hidden, are nested inside the other macro, which is the macros. So like that, in this kind of situations cannot be handled by the 2-pass macro processor. So what is the solution in essence? Let us take up the 1-pass macro processor. So what is this 1-pass macro processor in the sense? Let us not put the complete process of macro processing. Let's not put the complete macro processor functionality in 2 stretches. Let us do it in a single stretch. Because in the past two pass, what it was happening in the 2 pass? First, it has to complete the macro definitions. Then only it has to go to the macro calls. First, it has to identify all the macro definitions, then only it used to identify the macro calls. So that is very horrible with respect to the nested macros. So how to solve? Let us take up, let us do, instead of you split and do in the 2 steps or 2 stages, why can't we do it in the single stage or single stretch? Or as a single step? That is what? 1-pass macro processor. So you said as 1-pass macro processor. So where there's no means of you to split it. Let's handle both at the same time. But even if you want to handle both at the same time, there is a 2 kind of restrictions here. What is the restriction in there? What is the restriction here? It is what is the restriction here? It is in the sense. Before that, am I audible to everybody? Just any one of you just respond.
Yes, sir.
Yes, sir.
Okay, fine. So what are the restrictions here in the sense? The definition of the macro must be available in the source program. It is something like, so however you call it as, any function which must be defined before it is called. Can you understand from that sentence? So because what I'm trying to tell you in the sense, in a complete program, so first there should be a functional definition, then only there should be function calling. That's what the sentence says. So macro definitions must be available before any statement invoke the macro. That is what? Before the macro calling statement came to the picture. That's what in your program, here there is one macro calling. You're calling some macro as ABC, but before that invoking instruction came to the picture, before that itself there must be definition part of the ABC macro. That's what we said as a function must be defined before it is called. In the same way, macro prototype must be defined, must be available before it is invoked. That is what the first restriction which is to be taken care by a programmer. The second restriction is that they should not create any real inconvenience. What exactly is this in the sense? They're supposed not to be using the different using the same name for the different purposes. Here itself is one of the example that you can observe right here. Just because version is different, if you observe, this is where also this also read buffer, this is also write buffer, the two macros which are defined inside the one of the other macro. Here we are calling that as a macros, and here you are calling it as a macrox. It is macro x. Here it is macro yes. So what I see, it is clear cut solution. If at all if you are running in the SIC, then do make use of this. If you are running in the SIC, then do make it like that. Programmer himself had given the clear cut solution as where to use and what to be used. So like that, there should not be any kind of the problems which is purposefully created by the programmer. So those are the two restrictions which we need to take care. But the microprocessor, so remember, assembler performs the assembly process in the two passes, pass 1 and pass 2. Even if you want me to tell you what is that pass 1, pass 2 in the sense, in pass 1 of the assembler, what it does, it only assigns the addresses and generates the symbol table. In the pass 2, it is going to generate the object codes. In the pass 1, it just assign the address and generate the symbol table. In the pass 2, generate the object code for every instruction and write into the object program. That's what two passes of assembler. Whereas loader, coming to the loader, if there is a necessity of linking. I repeat, if there is a necessity of linking, that will be taken care in the that will be taken care by the linking loader. Then it will be loaded to the main memory. That's what you can call it as a loading process. Whereas coming to the macroprocessor, because it is also two passes, pass 1 and pass 2 in the sense, here it is no. So if you consider it as a pass 1 and pass 2 with respect to the microprocessor, it will be very difficult to handle the nested macros. But you can't expect the programmer to not to write the nested macros. There is a possibility of nested macros as well. That's what I said. A is the macro definition. From there you may be calling B. Again from B you may be calling C. Again you may be calling from the A, you may be calling the A itself. There is a possibility. Such kind of things cannot be handled by the two-pass microprocessor. So only instead of you split the process of microprocessing, let it be together, which is what? One-pass microprocessor. So this is where I just given the comparison. So in the two pass, what we did, so you first in the pass 1 you need to recognize the macro definition, in the pass 2 you need to recognize the macro calls, whereas nested macro definitions cannot be handled by the two pass microprocessor. Whereas one pass, what we did, every macro must be defined before it is called. That's what I said. Every macro, whatever you are going to call, before it must be defined. Then next is that every one pass processor is the obviously it is a alternate for macro definition in the macro expansion, and finally macro nested macros are allowed. So that's what you need to know here. Next, it is very important. You supposed to know about the data structures used by the microprocessor. So I hope you know that data structures used by the assembler. It was something if you remember sim tab and the op tab, symbol table and the operation code table. Again, with respect to loader, it is ES tab, external reference symbol table. In the same way, a data structure which are used by the macroprocessor, basically there are three data structures used, or you can say that three tables are used. That's what DF tab, which is definition tab, NAM tab, which is a name tab, NAM tab, you say that name tab or NAM tab, which is to hold the names, and third one is arg tab, which is to hold the arguments. So coming to the DF tab, NAM tab, and the and then arg tab are the three tables which are used by the one pass microprocessor. So what is this DF tab in the sense? That is the definition table, which is to hold the actual macro definition. So DF tab is to hold the actual macro definition. So whereas NAM tab, which is to hold the names, If I say names in the sense, it is the name of the macro. I hope you remembered from the yesterday's, from the previous session as such. So how do you define the macro? So there will be a macro keyword. For that macro keyword, left side will be label, which is the name part. Right side will be the arguments, which is the parameters. So that names will be stored in the name tab, which is the names of the macros, or macro names will be stored in the name tab. Is it only name in the sense? No, there will be one more thing, which is the starting address and the ending address. What I mean to say, see in the df tab itself, already you are saying that the actual definition of the macro which is stored in the df tab, right? What is the name of this macro? You store that in the name tab. And also what is the beginning address, what is the ending address, that also you store in the name tab. So name tab will give you the three fields. One is the name, then a beginning and end of the macro definition. Like that, three fields will be given in the name tab. So you call it as name tab or name tab. And third thing is the arguments. So these are the arguments which are actually passed from the invocation to the macro definition. So what I mean to say, at the time of macro definition, you might have used any kind of parameters which is started with the under symbol. But at the time of invocation, that's what calling the macro calling, you might have passed the actual arguments, which is the actual values, actual arguments. Those actual arguments which are stored into this argument tab, or you say that arg tab. So like this, these are the three tables which are used by the one pass macro processor. So it is df tab, nam tab and the arg tab. Now let us take up the simple example based on the previous study. So try to see the left part right now. Later I'll go to the right part. So from this left part, you need to make sure that this is where this is the invocation of the one of the macro from the previous session. So read buffer was the macro. Whereas it had three parameters. So for those for that you are passing the three parameters. See, for this example, and this is the beginning, this is the body of the control, this is the body of the macro, starting from clear x till this stx length. This is the body of the this is the body of this what I say, body of the macro. See, based on this, now let's just assume this is the name of the macro. This is the name of the macro. So store into the nam tab, which is the read buffer. So name of the nam tab, name of the macro you store into the nam tab. Then what are all the parameters we have, which is you call as arguments, f1, buffer and the length. Those you store into the arg tab. So as there are three arguments, you store those three arguments in the arg tab, which is f1, buffer and the length. Then this body of the macro, you put it into the df tab, which we call as a defined table. So this defined table holds the actual definition of the macro. This is the df tab which holds the actual definition of the macro. So starting from this to here, and I said nam tab doesn't have only the name of the macro, which also have the 2 pointer, which is the starting of the macro and the end of the macro. That is where the macro is starting and where the macro is ending. Like that, the macro processor will make use of these are the three tables, which is, I repeat again, nam tab, arg tab and the df tab. Nam tab will hold the name of the macro and starting of the macro, ending of the macro. Like that, every three parameters of every macro will be held in the nam tab. What will be there in the arg tab, in the sense it holds all the arguments whatever you may be passing. Here you may be passing only 3 arguments. So 3 arguments. You may be passing 10 arguments. So like that, what are the actual arguments you are passing? Those which will be put into this arg tab. And what does the define tab has? This define tab has the actual definition of the macro. So like this, the microprocessor do maintain these are the three tables. I repeat, these are the three tables or three data structures, you may call it as. Next, let me move to the very important part of today's class. It is the algorithms. So I hope you came to know till now data structures. We are going to use the three data structures, which is nam tab, arg tab and the def tab, or the defined table. Now let me come to this algorithm. Remember, this algorithm has working of one pass macroprocessor. Working of one pass macroprocessor is based on these 5 pieces. I say 5 functionalities. I repeat it as main program. Then there is a procedure. There are the 4 procedures. One is the main program and 4 procedures. 4 procedures are get line, process line, define and expand. Like this, there are 4 procedures with the main program. See, from this main program, you can observe this is what very importantly, you'll be calling get line once and you'll be calling the process line once. So you just forget about this, what is going to happen in these four procedures. So just see this main program. From this main program, what you are doing in the sense, for every line you are doing the complete process all together. As first you are getting the line and processing the line. It is you are not doing the different passes. It is because it is we are calling it as a one pass macro processor. It is not the different passes. It's a single pass. So it's a one stage or one step, one phase. So get the line and process the line. For getting the line, you may be calling this procedure. For getting the line, you may be calling this procedure, and process the line, you will be calling this procedure. Now, let's assume that get line, what it does in the get line, what it does in the sense, see this, you are going to get the line either, I repeat, either from the def tab or from the input file. What I mean to say, is it from the def tab or the input file in the sense? See, understand clearly, if the expanding is required, then only you will be getting the line from this df tab. Before that itself, what does the df tab has? Remember, it has the actual functions, sorry, actual macro definition. I hope maybe I may not be getting in detail. So try to understand from this point. So try to understand from this point. So as soon as you start your main algorithm, so you read the first line. This is the copy start 0. Done. So this is not the calling of your macro. So there is no need of expanding. I repeat, there is no calling of macro. There is no need of any expansion. Write it as it is. Again, read the next line, which is first STL return address. As soon as you read this instruction, again this is not the macro. So there is no need of expansion. Write it as it is. There is no need of expansion. Again, as soon as you read this read buffer, as soon as the microprocessor read this read buffer, and it came to know that this is the macro. So at the line number 190, it has to be expanded before this 185. It has this, whatever the macro which you are calling at the line number 190, it must be expanded. But if at all if you want to expand, I repeat, if at all if you want to expand, from where did you get it? From the df tab, not nowhere. From the df tab itself, you will get the expanded thing, expanded macro definition from the df tab. But so that is what that's what I repeat. Get line. What is the get line? What it does? Try to understand what it does in the get line. What it does in the get line in the sense, it has to keep getting the next line. But that next line, is it going to get it from the input file like this? See, in this example, input file instruction is copy start 0, first STL return address, LDA length, compare 0, JEQ end file. These are the instructions from the input file. Whereas start from here till here, these are not the instructions of the input file, because these are the instructions available in the macro definition. But where does the macro definitions containers are available? It is available in the df tab. So getLine method or getLine procedure should get the next instruction either from the input file or from the df tab. That is what your that is what this you can observe. As soon as you call this get line, what is going to do in the sense, if there is a necessity of expanding, then it will get. That's what, whether it is a expanding is necessity or not, that from where did you get it, that I'll show you that next. So if it is no, then get the line from the input file itself. If there is a expanding thing in the sense, then you need to, then for the expanding purpose, the next line you are supposed to get it not from the input file, you are supposed to get it from the df tab. Then that's what the get line. What about the process line? What happens in the process line in the sense, whatever the line you got, that whether you need to put it in the def tab, that's what. So that you need to put it in the def tab, or you want to put it in the put it for the expand. That's what, whether you want to call it as a define, and you will be calling the expand. So then you will be calling the, so then you will be putting, then you will be presenting everything or pushing everything to the output. Then what happens in the define? I repeat, what happens in the define in the sense, see what happens in the define record. Define record will not do anything. It just a means of just get the name of the macro, store it into the nam tab. Again, the content of the macro that you need to store into the df tab. Content of the macro you need to store into the df tab, and name of the macro you are supposed to store into the nam tab. Once after you store the content into the df tab, which is the starting pointer, and which is the where is the ending pointer inside the df tab, where exactly this macro is starting in the df tab and where exactly this macro is ending at the df tab, those two pointers will be assigning inside this nam tab as well. That setup you are going to do in this define procedure. And finally, what happens in the expand? What happens in the expand in a sense, this expansion can happen. I repeat, this expansion can happen only based on the arguments. See how exactly in the sense, see right here it was something like input device number, because that input device number, that's what this indiv. If you observe, this indiv is replaced, this indiv has to be replaced as what? F1. So if at all if you want to replace this indiv with this F1, so first the argument table should have the arguments. First argument table should have the arguments and with the respective index. This, so F1 is with the index, so that is the value of your indiv. Buffer is the index with the value as 2, which is the value of your buffer address. Length is the index with the 3, that is the length of your index of your record length. So wherever you are using indiv, so in your example, if you remember, this indiv we made use with this td and rd. So this 1 wherever it is here, it will be replaced with what? F1. Again, so here 2 is here. So this 2, what is the 2? It is what? The indexing with buffer. So this 2 will be replaced as what? Buffer. Again 3. This 3 length will be replaced with what? STX length, which is the 3. Like that, arguments will be expanded inside the macro definition. That will be taken care in this expand procedure. So I repeat again, this is the main algorithm. From that you will be calling the get line. What is going to happen in the get line? See, if you observe carefully, this get line is called from the main program and also it is called from the expand also. It is the only purpose is that. So when you call from the main program, it is always this else case will be executed. That's what you will be reading the next input line from the input file. Whereas when you call from this expand, at the time of expanding, you will be reading the instruction from the df tab, not from the input file. Whereas this process line, what happens in the process line in that sense? First you need to define the define tab and the that's what definition tab and the nam tab. Then only you can expand. At the time of expanding, what is supposed to do? Whatever the arguments which are used as a at the time of invocation, that you are supposed to put into the arg tab, and there will be respective indexes as 1, 2, 3 like this. So wherever there is a F1, you can see there that's what 1. Wherever there is a buffer, that's what 2, and wherever there is length, that is what 3, because of those indexers. So that is what happens in this expand. So in detail algorithm, let's see now. This is what the algorithm of your main. So begin the main macro processing. So at that time expanding is obviously false, because as soon as you start itself, expanding will not happen. For that expanding itself, there is a separate process. So until the opcode is end, you're supposed to keep reading the next line. You have to keep reading the next line from the input file. I repeat, from the input file, and you have to keep processing. And here you say that you are reading the next line with something like get line. You are reading the input line, which is by using the get line. What happens in the get line? Yeah, this is where the get line is here. So here, if inside the get line, what is happening? If you are performing for the expanding, then read the line from the def tab. And replace every argument with the respective positional notation. That's what 1, 2, 3, which I is shown in the arg tab. If it is not for the expanding, then read the line from the input file itself. So if it is not for expanding, then read the line from the input file. If it is for expanding, then read the line from the def tab and replace every argument related to the arg tab based on the positional notation. I mean to say, these are the positional notation. These are what? 1, 2, 3. This I hope you can observe. This F1 is replaced as 1. F1 is replaced as 1. Whereas this buffer is replaced as 2. Length is replaced as 3. That's what positional parameters. And always those positional parameters are presented with the question mark symbol. You will get to know about this question mark symbols and positional parameters in detail in the further concepts. But try to as of now, try to remember positional parameters are preceded with the question mark symbol. And from yesterday's session, I hope if you remember, parameters with the macros will be preceded with this and symbol, if you remember. Yeah, so that's what happens. That's what. Then coming to the process line, what is happening in the process line? In the process line, if you observe, so first you will search. So you will search in the search for the opcode. If the opcode is macro, if the opcode is macro, then you will go for the define. If not, you will be expanding. So that's what. If it is available, then you'll be expanding. If not, if it is macro, then you'll go for the define section. That is what. Whether you are going to fill the nam tab and or you are going to substitute with the nam tab and the def tab or a df tab. Then what happens in the define? This is the actual or the very important functionality to build the define table or a def tab. So you can observe, as soon as you call the define, first you will enter the name into the nam tab and you will start building into the def tab. And what happens in the def tab? Whatever the functional definition which is available from the macro definition, that everything will you keep pushing to the def tab. But at the time of pushing into the def tab, here this is where we are going to take care about one very important point you're supposed to understand, which is the level identifier. What is this level identifier? What is this level identifier in the sense? And these level identifiers are the one which are used to handle. These are the level identifiers are used to handle the nested macros. What do I mean to say nested macros and how to handle in the sense? That is what it is handled because of these two lines, which is if the opcode is macro, then we'll increment the level by 1. If the opcode is mn, then we'll decrement the level by 1. So actually how it works, let me take up an example and try to explain. If you take up this example, so this is MOCRO. So it is not spelling is different. So at least let me take up this example, at least because the spelling is correct. So it is macro. So if you observe this clearly, this is what we call as a recursive macro, or you may also call as a nested macros, which is macro inside the other macro. Now you have, if you see this clearly, this as soon as here you are starting the macro, here, the name of that macro is macro x. Whereas in next line itself you are starting one more macro, whereas the name of the macro is read buff. But somewhere here it is end. If you are using just because you got end here, now you how to identify, or how can you say, or how can the macro process says that this is the end? Is it the end of the read buffer macro, or is it the end of the macro x macro, or is it the end of both macros? How to identify it? Because you started or you initialized two macros with the two keywords like macro assembly directives here, but as soon as you encountered end here, now how can you say it as this is the end of the read buffer macro only, or this is the end of the macro x macro, or is it the end of both macros? How can you identify this? In order to solve this kind of problem itself, that level concept came into the picture. How? Understand this clearly. I said that as soon as this macro encountered, you increment the level by 1. So for this macro, as you came across with the macro keyword here, so increment the level as 1, which is the level of 1 which belongs to the macro x. Again you came across with the second macro, second time again you came across with the macro. Now again you increment the level by 1, so it will become 2. So level 2 macro is the read buffer, right? Then again you come, whenever you keep processing, whenever you encounter this end, whenever you encounter this m end, which is a macro end, but this is the end of which is level 1 macro, level 2 macro, that you can identify by just you need to decrement the current level by 1. I said decrement the current level by 1. What is the current level? It is the 2. If you decrement that by 1, it means to say that second macro is closed, whereas first macro is still alive. So in that way, you can say that this m end is belongs to this macro, not this. So you say that second level macro or level 2 macro is closed, which is read buffer. Again, you can observe. Again, once again macro came into the picture. So again, the macro level has to be incremented. By this, it has decremented, so it has become 1. By this, again, you need to increment by 1, it will become 2. Now again you understand. Macro with the level 2 is what? Right buffer right now. Again you keep processing. Again you came across with m end. You're supposed to decrement the level by 1. You're supposed to decrement the level by 1. So it will become 1. So it means to say that this is closed. Again you keep processing. And again you came up with the m end. So it means to say that decrement the level by again 1. So it will become what? 0. So once the level becomes 0, then only you can conclude that this nested macro is processed completely. Macro processor has processed this kind of nested macros or recursive macros completely or successfully when level became 0. That is how the macro definition or nested macro definitions are handled by using this define record. So let me read it again. So you will be storing the names into the nam tab and macro functions into the def tab, and you will be this is where you have to understand very importantly, until the level is greater than 0. So until the level is greater than 0, you will be keep performing. So so whenever we come up with any kind of positional notations of the parameters, then you will be keep pushing to the def tab, and if the opcode is macro, you will increment the level by 1, and even the opcode is m end, you will decrement the level by 1. Rest everything you will be keep pushing to the def tab. Rest of the process it is just keep pushing to the def tab. Once this level becomes 0, that is what the end of that macro definition. That is the end of the macro definition. So that end pointer should also be stored into where? Nam tab. I hope you remembered. In the nam tab, we'll be storing what? Both beginning and also end pointer. That also will be stored into the nam tab. That will be done in this define code. And finally, expand. This expand, which I already said. So which actually. So first you need to build the arg tab based on the what are the parameters will be passing. Then based on the parameters which are our arguments available in the arg tab, and based on the respective index, I say it as index or positional parameter or position notation number. So those notation numbers has to be replaced, and that will be done in this getLine. You can see substitute arguments from the arg tab based on the position notation, because this getLine is also called from the expand. Now if you get any if you have any something like doubt, like, so I said here from the main program also you'll be calling the getLine, from the expand also you'll be calling the getLine. If you understand, you will be calling the getLine from the main function, or also from this expand function you will be calling this getLine. But when you call this getLine from the main, you will be executing only this. You will be reading from the input file, not from the def tab. When you call this procedure, the same procedure getLine from the expand, so you can observe you're calling this. So at that time you will be reading the line from the def tab for the expansion. So at that time only this will happen. So what is the expansion is happening? You are substituting every argument in the definition based on the argument position parameters available in the arg tab. That is what I say. So that's what happens in the getLine. So this is what I already said, how we handle this nested macro definitions by using this define procedure. Already I said. So whenever there is a macro, you just increment the level by 1. If there is a assembly directive m end, then you will be decrementing by decrement the level by 1. Once the level reaches to 0, then only you say that macro definition is end, and you can terminate the define record. If not, that will be keep continuing until the level becomes 0. That is what I said. How we are going to handle the nested macro definition by based on the defined procedure. So like that. So here you're supposed to know that there will be 4 procedures and 1 main function. I can say it as that only 5 procedures which will be included in this algorithm. Algorithm belongs to the 1-pass microprocessor. Guys, are you understanding? So as of today's session, this is where the last topic which I would like to highlight. So tomorrow, let's see. That's what in the next class we are going to see this machine independent macroprocessor features. The next session, let us see about the machine independent macro features. So today we saw about in the last class, in the last session, we discussed about the complete processing of the macroprocessor. So whereas today we started with macroprocessor design. First we said about the 2-pass microprocessor. If you consider as a 2-pass microprocessor, what happens in the pass 1, what happens in the pass 2. But this is it is very difficult to make it in the 2 passes for the nested macros. So that's the example which I said. And so only solution part we came up with a single pass or 1-pass microprocessor. So when I say that 1-pass microprocessor, this is a simple comparison which I made it with between the 1 pass and the 2 passes. And the data structures used by the microprocessor are these are the 3 data structures: def tab, nam tab, and arg tab. And with an example, I said how we are going to generate the nam tab, def tab, and the arg tab. Then coming to the algorithms. So as a part of algorithms, there are totally 5 procedures. One is the main procedure, and the 4 I call it as one is the main program, and the 4 are the procedures, which are get line, process line, define, and the expand. And finally, I said about how we handle the nested macro definition by using the define procedure by increment and decrementing the level point. So that's the end of today's session. So in the next session, let us deal about the machine independent microprocessor features. So let's see this in the next class. So okay, before I wind up, any doubts? Yes. I don't know who exactly is that. So somebody you unmuted your audio, so only I'm getting so much of disturbance. So fine, you may be having some problem with the audio. You can also post me through the question through the chat right now. Let me answer that right now. Yeah. Any question? Any questions on the topics which we discussed today?
Sir, what was that question mark in the example which you were showing while expanding the?
Yeah, so question marks which I shown here, these are what you got as the positional parameters which will be preceded with the question mark. See what I said, positional parameters. So as of this example, if you observe the positional parameters, it is 1, here it is 1, and this is also 1, again here it is 2 and 3. These positional parameters based on the arg tab. And arg tab at the position 1, what you have it is the F1. In the yesterday's class, I said this is the defined macro. First position it has the indiv, second it is the buffer address, third it is the record length, and those parameters must be preceded with the not at the rate, and symbol. That's what I said. Parameters of the macro definition must be preceded with the under symbol. Whereas this is what the calling macro or macro calling, which is a macro invocation. First one, which is F1. Does my screen is visible, right?
Yes, sir.
Yeah, F1 is a parameter. F1 is the argument which is to the parameter of indiv. Again, buffer is the argument for the buffer address. Length is the argument to the record length. See, by you as a programmer or you as a looking to the program, you can say that these are the 3 in order arguments to these 3. But how come your macro processor will come to know that which is the first, which is the second, which is the third? So for making sure that which is the first, second, and third, it should have the respective numbers. So what it will do in the argument table, it will start storing these into the argument table. First it will store f1, again second buffer, again length into the third. So based on the position, what is the position? It is the f1, it is in the first position, buffer is the second position, length is in the third position, like that. These are the positional values. I call as the positional parameters. These are the arguments and these are the positional parameters 1, 2, 3. And those positional parameters can be used in the definition section. If at all if you want to use the such kind of positional parameters in the macro definition section, you have to proceed that with the question mark. So like this 1, 2, 3, sorry, we have 1, 1, 2, 3 like this. These are not the positional parameters. This I said in the last class as this is for the referencing, which is forward referencing and the backward referencing. This is the backward referencing. This is the forward referencing, which I said in the last class. Whereas these are the positional parameters which I am talking about, which is preceded with the question mark.
So why it is -3 plus 11?
I hope I said yesterday. Okay, let me elaborate again. Yeah.
Like the forward referencing and backward referencing, like it is
exactly
given as -3.
Yeah, that's what I repeat. See, remember, it's supposed to be JEQ. This is jump if equal to some loop. That loop to where it has to jump, in the sense, see here it's supposed to be one more label, and there is, by making of this kind of notation, you don't have to make use of one more label, because this JEQ -3, in the sense -3 bytes, because by looking to this itself you can make it out this is also format 3, this is also format 3 instruction. You understand, from the normal perspective, it is the jump if equal to some loop. Where is that loop? This is what it is pointed to, this TD. It is what? Jump if equal to this test until this TD is true. When does this TD will be true? When the control flag or the condition code is set as less than. When it is set as equal, it is what the TD test device. When it is set to equal, you need to keep testing, right? So this is just like jump if equal, and I call this as a R loop. And where is that R loop? This is where R loop. Just because of that, or in order to avoid that, using the separate labels and identifiers, we can use this kind of notation by using this backward referencing as JEQ -3. Minus is for backward referencing. How many bytes you need to go back? It is for 3 bytes. So when you go back for 3 bytes, it is what? This instruction. Again, if you take up this JEQ +11, if you have any doubts, it is JEQ +11. It is jump if equal to the end. And where is that end? It is the end of this control section, the end of this macro. So it will come to this LDA length. Try to understand this JEQ +11. This is for, this is where end. This is the end. So jump equal to jump to the end. This is where end. So how many bytes you can observe? This which format is this? Format 3 bytes. Again, which format is this? It is format 2. 3 plus 2, 5. Again, here it is format 3. 5 plus 3, 5 plus 3, 8. 8, again, this is STX length, which is format 3. 8 plus 3, 11. So to come from this instruction to this, you're supposed to pass through 11 bytes, which is, again, it is a forward referencing as well. So you need to jump if equal to, and you need to jump how many bytes? You need to jump for 11 bytes, so that you will come to this instruction, which is LDL length. Again, here is an example, JLT -19. So where you will be jumping back to this TD. You'll be jumping back to this TD. So how does this 19? It is what you can say. It is what? Format 2, 2 bytes. Format 3, 3 bytes. 5. Again, format 3, 8. Format 2, 10. Format 3, 13. Format 3, 16. Format 3, 19. Like that, 19 bytes will be jumping back. You'll be jump back to the 19 bytes. You'll be going backward. So it is what? Backward referencing, -19. Yeah, did you understand?
Yes, sir.
So that's what you just have the difference. These are forward referencing and backward referencing in the memory. So to go further for the execution, or to go back, how many bytes you need to go further for executing, or how many bytes you need to go back. That's what forward and backward referencing, plus and minus, and these numbers are byte numbers. How many bytes you need to go back and how many bytes you need to go front. But these question marks is the positional parameters. So to specify the positional parameters of the argument table, you'll be using this question marks. Is it clear?
Yes, sir.
Yeah, guys, any more doubts?
Sir, already we are having subroutines. Then why are we using macros, sir?
Yeah, again, this itself, as in the last class I said, see, for the macros, for the subroutines and all, you will not be passing any kind of parameters. You may be calling that for doing some action, so to do some particular purpose. So what it will happen in the sense, yes, it will do some kind of purpose, it will be called, but you will not be passing any particular arguments from your end with respect to your subroutines. So you'll be using the macros, and also, so macros, hello, you can hear me, right?
Yes, sir.
Yeah, whenever you make use of macros, this kind of expansion will happen, and that based on the respective arguments, that expanded values or expanded arguments will be replaced, like the and that's what a previous let me go back to the previous example. Yeah, this is here itself. If you observe this, here is the three parameters like indiv, buffer address, and record length. But what you are passing is f1, buffer, and length. So f1 will be replaced wherever you are using indiv, buffer will be replaced wherever you are using the buffer address, and length will be replaced wherever you are using the record length. See here, if you observe, this is just like a blueprint. You understand, this is just like a blueprint based on the parameters you pass. Here I may be passing as f1 buffer length. Somebody may pass it as f2 something, and instead of buffer he may call it as a record, and instead of length he may say that something else, record length values he may pass it something else. So in such case, so those arguments itself will be replaced wherever you're using these parameters. This you don't find in the subroutine. So it is just like a blueprint, can be used by anybody for their own purpose, or their own, instead of I call it as purpose, their own parameters, their own arguments. Are you understanding?
Yes, sir.
Yeah, any more queries? Yeah guys, any more queries? Okay, if there are no queries, then you can leave the session.